Hi, in this video, I will do a quick introduction to organic chemistry, which in my opinion is basically one of the most important fields of chemistry. And in fact, a lot of students, and including myself, fell in love with chemistry after organic chemistry. So first, let's define what organic chemistry is. So here is a very basic and classic definitions of the field organic chemistry. It is the study of structure, property, composition, reaction, and preparation of hydrocarbon, and sometimes there can also be another element in it, including nitrogen, oxygen, halogen, phosphorus, and so forth in it. So that's what the field of we will be covering in organic chemistry, the studies and the preparation of these organic substances. Now, but if we were to define what organic chemistry is, then a lot of people would actually define organic chemistry as the study of electron and how they interact. Yes, that's right. Organic chemistry is the study of electrons and how they interact. And because organic chemistry is the study of electron, and an electron behaves in ways that are very predictable, and it makes sense. There's a lot of logic to what's happening with electron. And so if we were to see the field of organic chemistry in terms of electron, it makes complete sense. And this is when we'll be able to make predictions and everything would come together. And we don't have to end up memorizing one reaction after another, but simply just focus on the electron and ask yourself how this electron will behave. And learning everything about electron, and will be able to make sense and really enjoy organic chemistry. Now, why electron? Why is organic chemistry the study of electron? Here are the reasons why. First, every chemical substance has its own electron cloud, and the electron cloud can be further described by something that we call the electrostatic potential map. And these are examples of the electropotential map right here of these different substances. And they have this electron cloud right here due to the bonding and the composition of the atoms that make up this chemical substance. And depending on the distribution of the electron density on each substance then have certain stability or potential energy to them, and therefore they have certain behavior to them. For an example, in this case right here, we see this is ethane, and for ethane, it consists of carbon and hydrogen. And overall, this would be the electron cloud of ethane. Now, when we move on here to methanol, so this molecule is methanol. And in the case of methanol, it has oxygen, and it have this hydrogen right here. And because of the presence of this oxygen right here, this oxygen right here is electron rich. And in fact, it is much electron rich compared to the carbon and the hydrogen. And therefore, you will then see this area right here in the electron cloud of the substance that turn out to be red. And on this electrostatic potential map right here, any region that have the red color in it indicate that that region right there is rich in electron. So if it's red, then it is rich in electron. Versus if it's blue, then now it shows this region right here is then poor in electron. And overall, this is the electrostatic potential map of the substance. So we have this region in green right here, and for green, meaning it is pretty much neutral, where electrons are evenly distributed. But then on this oxygen right here, it is rich in electron, and on this part right here, so this is where this hydrogen would be. It is poor in electron, and therefore it has this blue color coding right here. So this is the electrostatic potential map of this substance. And moving on to water. So for water, we have an oxygen and two hydrogen, and this oxygen right here is rich in electron, which make this part right here red. And now the hydrogen in here, because once we have what we have seen already, this molecule right here polar, and this hydrogen right here is partially positive, and because of it, it is then electron poor, And so if we were to now look at the electrostatic map of this, we'll then see the hydrogen are then in blue and the oxygen is in red. And here is the different substances, and here is acetic acid. And in the case of acetic acid, this oxygen, one of this oxygen right here, is very rich in electron, and that is this oxygen. And this hydrogen right here is then poor in electron. So overall, every chemical substance has its own electron cloud that is then described by this electrostatic potential map. And each electron, depending on the distribution of an electron, it has certain stability to it. And whenever we mention of stability, we often think of potential energy. The higher the potential energy of the electron or the electron system, then the more reactive it will be. Now, so chemical reactions are then driven by the instability of the electron in a given system, because every substance has its own electron cloud or electron system. So if the electron system of the substance is not stable, so when we take the substance and we mix it together with another substance, they will then react. And in chemical reaction, as the chemical reaction is happening, what happens is that the molecule is trying to shuffle or to rearrange its electron. So that way, it can have a more stable electron cloud that have better stability. So basically, the more unstable the electron would be, the more reactive the system would be. And the system would then try to find a way to shuffle or rearrange those unstable electrons for better stability, causing a chemical reaction to take place. For an example, let's say here we have these two molecules and we react them together. So molecule A has its own electron cloud. And here in this particular molecule right here, we can see that this molecule right here is not stable. Yes, that's right, it's not stable. Because here's what happened right here. Molecules, they have electrons evenly distributed throughout. Those are the more stable substances. For an example, in the case of this ethane right here, this is a stable substance because every part of it is green and the electrons are evenly distributed. And here, with this CH3 group right here on this molecule, it's also green too, meaning the electrons are evenly distributed, and that's what makes it stable. So here, in this particular part right here, we see that this entire part right here, this molecule, it kind of greenish or yellow, but meaning the electrons are somewhat evenly distributed in there. However, this region, due to a particular atom in this, and it turned out this would be the chlorine. And because of this chlorine right here with lone pair electron on it, and so this have a much bigger electron cloud. And now that caused the electron distribution for this molecule to be in this particular way, where it now shifted to this chlorine. And that makes this molecule right here polar, right? And that basically means that electron is polarized to this particular chlorine right here in this molecule. And so anytime you have electron that build up on one atom or a region in a molecule, then that makes that molecule not as stable. And if we were to now take this molecule A and react them with this molecule B, so in this case right here, this is methoxide, and in the case of methoxide, you have this oxygen right here, the negative. So this shows us that this is rich in electron. So in the end, we also see that this molecule right here is highly polarized, where the electron end up on one region of the molecule, but not evenly distributed throughout the molecule. So that makes this molecule right here unstable as well. So when we take these two unstable molecule with unstable electron cloud and we react them together, they may end up exchanging electron with each other and shuffle the electron together in such a way to now create something that's more stable. So this is what happened in the course of this reaction right here. So if we actually look very close carefully here, one of the hydrogen in this particular part, so this particular part, this molecule right here, had region, they somewhat blue in here, right? So this is greenish and this bluish. So this tells us right here that this part right here is more partially positive. So this is partially negative right here. And when we take this two molecule right here with this polarization of the electron, then what happened is that because this oxygen, this part right here, rich in electron, it end up getting attracted to this positively positive in the other molecule. So therefore, they come in and they react with each other. So in the course of this reaction, this oxygen from this molecule is then donating electron to this positively positive hydrogen is this molecule right here. And that would then give the electron to the chlorine and kick it up and producing this reaction right here. And we'll learn about this reaction later, and this is called an elimination reaction. But in the end, this molecule, once it loses the hydrogen, it now becomes this molecule and a double bond. And as for this molecule, it now becomes the following. So if we were to basically now compare the electron cloud between all of the molecules on the reactant side and the molecule on the product side, you will then see on the product side, it have a much smaller polarization of electron. Now you can see that this part right here is somewhat, it still have some double bond in here. So this part right here is rich in electron, which again is not preferred. But this is much better than the buildup of electron on these two regions right here on the reactants molecule. And now over here on this oxygen, we have this oxygen right here. They're still rich in electron. But at least when we combine both of this electron density together, they are much smaller than the molecule that we would see on the reactant side. And that's what makes it stable right there. And that is the driving force of this reaction. Okay, and so if we think in terms of potential energy, the reactants, they are not as stable due to high polarization of the electron. So now they have high potential energy, and this is why that we draw them a little bit up on this scale. And at the course of the reaction is happening, now we produce a product C and D. They have lower potential energy, they are more stable. And that's the driving force for this reaction to happen. So you can see that this example right here shows what is happening in the course of a chemical reaction. That in fact, electrons are getting shuffled or rearranged for better stability. So everything is driven by stability. So in conclusion, to be able to understand and really make organic chemistry fun, we need to be able to understand and predict, to be able to predict and understand our chemical reaction, we need to know about the electron. And now, there are three questions in particular that we want to know about the electron. First, where are electrons in a substance? As we learn organic reaction and organic molecule, we need to be able to see where are the electrons in a chemical substance. Really important. And second, we need to be able to determine how stable are those electrons. Because if the electrons are stable, then there won't be much reaction that the molecule would undergo. Versus if the electron in the molecule are unstable, then that's when we can see it will undergo very rapid chemical reaction. And lastly, we need to learn how do electrons move, because in the course of the chemical reaction, electrons are moving from one molecule to another molecule. And electrons move in a way that are very predictable and in a particular way. So, and that make complete sense. So it's not random or anything, but an electron move in a particular way. And so we need to also learn how electrons move. So first, know how to identify the electron, know how stable all the electron would be, and then learn how electrons move. And these are the three most important questions that we need to be able to answer. And once we can find the answer to these three questions right here, we will be able to understand and do any organic reaction. So everything that you have learned before, or everything that you will learn here in this class, it to basically help us answer these three fundamental questions right here. And once we know them, we'll be able to understand organic reaction. So in the end, everything really come together in this class. A lot of concepts that we have learned from JetChem will now be used here in organic chemistry to understand all this reaction. And that's the part that makes organic chemistry really fun and easy for many students.